things about probability. For example, you're all grabbing it. Back on again. You're all grabbing a die. Yes. You're all grabbing a die. 2 dice actually, but in order to grab 2, you had to grab 1. So tell me everything you can about these things.
Cube.
Cube.
Has 6 sides.
So that's 6. Good.
With 6 different numbers on them.
What about those 6 sides?
What?
They do. And we almost got in a fist fight last class about this. It was so cute. They were so fired up about it. It was great. Why is it 1 through 6? I don't know. It just is. And they were getting, but what if you put 2 through 12 on it? Like, go ahead. Make them all twice as big. Well, that would change. Yeah. They were getting like fired up. Like, hell yeah, it's week 6 and you're fired up. That makes me happy. But they were getting like almost violent. Sorry, guys. But yeah, I mean, you can put whatever you want. You can put colors on it if you want. You can put animals on it. But these just don't. These have 1 through 6 on them. So there you go. Beautiful. Beautiful. What else?
They add up to 7 on opposite sides.
Do you ever notice that? On a die, the 1's opposite the 6, the 3's opposite the 4, and the 2's opposite the 5. Why? I don't know. It's just that's the way they're set up. I don't know. It's just like it's code for making dice, I guess. What else? What else? Austin? Why do we gamble with it? Good! It's purely random, just like the coin in front of you is. It's purely random, just like the coin. And when you put a pair of them together, it gets even better. We'll see if we get to this today. I hope we do. We'll see how time goes. But when you throw these dice, I just roll 5. If I was playing craps, I'm still in the game. I'm still in the game. Now I got to roll 5 again before I roll 7. Just roll 6, still in the game. Just roll 5. I just won. Okay? Didn't bet anything, but I just won. And you can see that happened very quickly. And I just won playing craps, which explains the crowds around craps tables. Because it's very easy to win. Unfortunately, it's the tiniest bit easier to lose. And Vegas knows that. And Vegas controls that. And they control the house edge. And then they control the payouts based on the house edge. And all these terms I'm using right now correspond exactly to what you guys have to deal with every time you pay a car payment. Okay. You ever notice your car payments change? Maybe. Sometimes they don't. I mean, usually annually they don't change, but then after like 5 or 6 years they might go up or down. Something like that. You ever wonder why they go up and why they go down? Sometimes, go ahead.
Interest?
Sometimes, in what way? Interest in...
Your principal payment?
But why would it change? Why would that principal payment change?
Because you're making a payment, and the more payments you make, the less balance you have, so the less interest you have to pay.
For car insurance.
Oh, I thought you said car payment.
Oh, no, car insurance!
Gotcha.
No, not car payment. I'm sorry, car insurance. Car insurance, I'm sorry. No, not car payment. I don't understand banking and economics. Sorry, I'm an idiot with that stuff. Car insurance! It does in a lot of ways, but how do they make their call about how much you should pay?
There's a lot of
Somebody just said accidents? Credit? I don't understand that. Let's ignore that because I don't understand it.
where you live.
Where do you live? Why would that matter?
Because if you live on a busy street, then you have more probability of
Oh!
getting in an accident.
You're telling me probability has something to do with how much you pay every month for your car
I'm from
insurance?
Sacramento, and if you lived on there was a street that was about 4 or 5 miles long, and if you lived off or on that street, you paid automatically like $17 to $30 more every month.
If I roll a 5 or a 6, I live on that street and pay more every month. Damn. Pay more every month. Boom. You see what I just did? I made it comical. But that's essentially related to exactly what Carolyn just said. If you so happen to have the probability of that street, an accident, being in a certain age group, being a certain gender, statistically linked to these things are probabilities that govern how much you pay. So what is the insurance company essentially doing with you when you sign up for them?
Robbing you.
Careful. They're taking a chance on you. So they have to weight that chance with a premium payment to make sure they make money. Why do they have to make money? Well, they're a company. That's a good answer.
They cover you.
They have to cover you and everybody else that's under them in the event of an accident. So they have to make sure they collect enough from you to create that pot of money to draw from and also keep the lights on and pay their employees and all that stuff. So it's all about balancing these odds. And believe it or not, it all comes down to this, logically. The same math that governs what you're holding in your hand, this pure random item in your hand, or the coin for that matter. The same math that governs your insurance payment. It's kind of crazy to think about, but that's exactly what it is. It's the same idea that was it Pascal? Some famous philosopher said it pays to believe in God. Oh, we'll have to make this a quiz. Because on average, you lose less believing in God than not believing. Oh, I gotta go find the quote, and I'll make a quiz out of it. But it's amazing how this idea of distributing probabilities evenly across a pie chart, across 100%, can be analyzed and averaged and analyzed in that way. So that's what we'll get into today. Everybody got some dice and a coin? Start with one die. Here's what I want you to do. We're going to generate some random numbers. Roll the die 10 times and keep track of what you get.
Just one.
Just one of them for now. We'll add the second one because it makes it more. We'll roll one die 10 times and then just keep track of what you get each time, okay? Collect some data.